All right, hello and welcome to CapTech's webinar series. This edition is on Big Data Value Realized, empowering DataStax Enterprise and Apache Cassandra in the enterprise. I appreciate everyone taking the time out of your day to attend this event. Our webinar today is going to be about 1 hour, and we'll be covering some brief introductions for myself and Todd Homa, my colleague that's going to be presenting. We'll talk about big data, why it's important, the value around big data, and why you may have been hearing about it. We'll talk specifically about Cassandra in the enterprise. Cassandra is a NoSQL solution and why that might be important in your enterprise. And then we'll talk about our experience that we've had implementing Cassandra at one of our telecommunications clients. And then finally, we'll cover off on the approach to a successful big data integration and some of the key things that we look for when we're going out to engage with our clients. And then we'll open it up for questions and answers. So throughout today's webinar, we encourage you to use the chat to submit any questions that you might have. And at the conclusion of the event, we'll answer as many of those as we have time for. We also encourage everyone to share your thoughts on Twitter, hashtag CTWebinar, and you can also find us on Twitter at CapTechListens. And if you're interested in re-listening to this later, we'll have a recorded version of the webinar available on our corporate website next week. So with that, let me do a quick introduction. My name is Ben Harden. I'm a managing director at CapTech. I've been in the data management space for over 15 years, most recently focusing on big data Hadoop installations, and really looking forward to talk to you guys today about the work that we've been doing in the big data space. Todd, do you want to go ahead and introduce yourself?
Sure. This is Todd Homa. I'm a senior manager with CapTech. I have about 17 years of experience in data, typically doing data architecture. I've had the privilege of working with big data tools for about 2.5 years now, and I'm really having fun with it.
Great. Thanks, Todd. So before we get started, I just want to do a little background on who CapTech is and who DataStax is. So CapTech, we're a consulting firm, almost 500 consultants based in the Mid-Atlantic with a national traveling team that works around the country. And we're also a full services consulting firm, so I know today's focus is going to be primarily on data management, but we also have an IT management consulting arm, a systems integration team, as well as data management. And I think it's important to call that out because when we're talking about big data, the work that we do in the big data space draws upon all of these practice areas, whether it's the need for Java development, management consulting around agile methodologies, or the traditional data management work that we're going to talk about today. A little bit more about DataStax. So if you're not familiar with DataStax, they are the premier enterprise distribution of the open source Apache Cassandra NoSQL solution. They pride themselves on providing endlessly scalable NoSQL Cassandra distribution that focuses on high availability, and they are roughly 300 employees and have over 500 customers. So for those of you that have been following the big data trends, things are growing very quickly, and DataStax is on the front edge of the NoSQL solutions. So what is the value around big data? Why is it so important? I'm sure that if you've been reading in the news or following on the web, you've heard about all of the buzzwords that are out there. So what can we do with big data? How can we get more information into our enterprise? How can we learn more about our customers? How can we learn more about our customers quickly? How do we consume all of this unstructured information that's coming from around the world, whether it be through sources like the web or through the Internet of Things? How do we keep things up and running all the time? And how do we quickly respond to our customers' needs? Because we know that the faster we can respond to them and give them the service that they are interested in, the higher customer retention rates we're going to have. So these are all the types of things that big data solutions are promising and that companies are looking for and looking to engage a big data solution to try to deliver. So how does that translate into what we're seeing in the marketplace? Or go ahead, Todd.
Hey, sorry, Ben. I just wanted to chime in and say that we'll actually be addressing some of this promised value in the use case later on. where our clients specifically had concerns about being able to scale for the customer base and having 100% uptime. So we'll make this real later on.
Great, thanks, Todd. So moving on to slide 10. So how does this fit, and in what different verticals could big data be applied? We've got a number of examples here. I'll just go into a little more detail about the financial services example, as that's one that I have the most experience with. So Fortune 500 bank implementing a big data solution was able to more quickly understand how new customers were using their credit cards and be able to predict whether or not they were going to be high-use customers or whether they were eventually going to stop using their cards altogether. They were able to do that prediction using a statistical model very, very quickly. So within the first 30 days of the customer signing up for the credit card. And then if they came to a prediction that this customer was not going to be using their card, they could proactively reach out and try to understand why and increase customer retention rates. And they've had a lot of success doing that. Other areas, healthcare. So utilization of insurance, how do we model that? Is there a way that we can make sure that we're paying benefits appropriately and reducing our costs? Retail and e-commerce, I think these are the easiest examples. So things like what are the patterns of our buying? What are, if I'm at Amazon.com and I've bought diapers, might I also be interested in wipes? Those type of things. The case study that we're going to talk about today, that Todd's going to talk about, is in the telecommunications area. And so this is a case study on how we were able to capture information on customer behavior, better understand how customers were using their DVR, and in general be able to improve the customer's experience. And Todd will go into the real-world application of that in a few minutes. So with that, I think I'll turn it over to Todd and let him talk about some of the pitfalls that we've seen out in the field when implementing these solutions.
Thanks, Ben. So I personally have been involved in about 4 implementations of Cassandra, different business groups, different customers, all different situations. And through those implementations, I've learned a few things that I think would be applicable moving forward with other NoSQL implementations or big data implementations. The first one being, I think it makes a lot of sense to engage the business up front and to work with them to understand what would be valuable. Because I think moving forward with the POC or even with a full-fledged project, having goals in mind and being able to measure those goals against business value is the best way to get support both in the business and in IT and furthering the big data implementation. The other thing that's really important is to include not just the development team. A lot of these tools are developer-centric, but you have to engage all the downstream consumers because this is a fairly decent change to the architecture, and we want to make sure that we are not adversely affecting anybody downstream and that they're well aware of the changes that are coming and how they can deal with those. We also want to make sure that we address the analytic functions of the organization. A lot of these tools change the analytical paradigm. In other words, how we do analysis of the data, how do we query the data. And it's important to understand how we're going to meet those functions as we move forward. Otherwise, the business won't have any insight into the data. The tools are new, processes are the same. We don't want to throw out all the data governance practices that we've built over the years with the relational database world. We want to make sure that we still have data governance and data provenance, stakeholders, systems of record, documentation. It's all those functions still apply in the big data world, and that we need to make sure that those are addressed in the implementation so that we don't find ourselves in a situation where we're not able to document all of the data assets that we have. We also want to engage the resources we typically engage in a development process. So typically, any project where we're going to have a persistence platform like a database, we're going to typically involve data architects and modelers. The data architects are going to make sure that the tools and the processes being used fit in with the overall enterprise architecture. and the modelers can provide insight into the data that's currently available in the enterprise and make sure that the data that we're putting in place has also got exposure throughout the enterprise. One of the biggest challenges is trying to hire people that have these skills. We basically recommend that you try and find people that are motivated and dedicated in the company and invest in training them up. It's a much easier and a much cheaper proposition than trying to go and recruit experts in these tool sets, because these tool sets are relatively new and they demand a high dollar value. So it's better to bring in somebody and do like a training and try and build the skills internally. It helps with morale, and it's cheaper in the long run. One of the other interesting things that happens with most of the big data tools is that they are very scalable, which means there's a lot of things. So a lot of nodes, whether it be Hadoop or NoSQL, there are going to be a lot of machines that are running the platform. You want to make sure that you address the operational and maintenance aspects of those machines because you don't want somebody to manually be updating hundreds of machines. So we want to make sure that we have a tool and a process for managing the influx of machines that we'll have. So now I'll go on to specifically what having NoSQL or big data tools, Hadoop, in the enterprise looks like. We tried to create a high-level diagram that illustrated where the tools fit. In theory, you could draw lines between any of these components and have a spaghetti architecture. I don't think there's any value in that. What we want to illustrate is that there are different sets of data and different tracks for that data to flow through the organization. So specifically, we have the transactional data that we think of traditional volumes of transactional data where we use batch ETL tools, whether it be Pentaho, Informatica, or Microsoft SSIS. We process that data in the ETL platform. We load it into an operational data store maybe, or we load it into a relational database, and we make that data accessible to users through an OLAP BI platform or ad hoc platform, and users are able to typically access the data through SQL. That's how we've done it for years, probably decades at this point. Other data, so that some of the interactive data, the high volume social media data, device data, or unstructured data, the things that are driving the use of big data tools, flow through a slightly different process potentially. They could, well, as I mentioned before, you could do spaghetti lines between all these. But traditionally, they'll go through things like Flume or Storm or Kafka for essentially acquiring the large amounts of data. That data then gets persisted in something like NoSQL or Hadoop or both. Maybe it's even processed there and cleansed. And then ultimately, that data is made available through the same interface that the traditional data was made available. So what does that mean? Do we load it into the warehouse, or do we provide additional tools? There's many different ways to attack it, but the general flow still remains the same. So now I want to look at specifically what Cassandra is and what NoSQL is, because this is the focus of this specific webinar. Future webinar we're going to do is going to look at Hadoop. So NoSQL is difficult to define, but a simple Wikipedia kind of query will result in something that you see here, where it's a non-relational database that's going to relax some of the traditional RDBMS principles to gain some other benefits. And typically that's performance and scalability. They come up with acronyms to try and make this simpler to understand. Most of us probably know ACID. ACID is what we use to describe a relational database system. I won't read these off to you, but basically it refers to guaranteed persistence and consistency attributes of a relational database management system. These principles have been in place for over 30 years. NoSQL takes a different approach. They tried to come up with a corollary called base. It doesn't line up quite as nicely as ACID, but it illustrates the point where we have something that's basically available. And what this means is that the system guarantees that it will always be able to answer a question, so a query. So it is always available. It's soft in the sense that even if you do not directly write to it, it is possible that the back-end processing is doing things to the data that will change the state of the data. So it's not, it doesn't follow the isolation principle that you see on the right. It is also eventually consistent. You can make these consistent. However, by making something consistent, you degrade the performance potentially. So they trade eventual consistency for performance improvement, eventual consistency being eventually all the nodes in the system will provide the same answer to you when you query them. But initially, that may not be the case. So that's the high-level overview of what NoSQL is. There are a large number of NoSQL tools out there. I'm sure everybody's read all the articles and done queries on NoSQL, and tons of stuff come up. There are 4 major categories of NoSQL tools, although you can break them into smaller groups. Top one being key value, simply just a key and a value, things like Redis and Dynamo, React. They basically store associative arrays. They're literally meant to, you give them a key, you get a value back. You have things like document stores, like MongoDB, CouchDB. They're kind of a derivation on the key value, where the value is a document, the key is a tag. So you're basically tagging documents so that you can get them back very quickly. Those documents could literally be Word documents, or they could be JSON or XML. The next category would be something like graph databases, where you have data points or entities, and you have lines and relationships between those, and you have data about those relationships. So they're really for things like logistics and social media relationships. An example of that would be Neo4j. The last class, and the class that we'll be focusing on, is Columnar. So Columnar databases would be things like Cassandra and HBase. In this case, the data is pivoted, and we're basically looking at data stored as columns as opposed to rows. There still are rows, but the columns themselves are a tuple. They contain a name of the column value, and the column timestamp itself. So in this use case, we cover specifically Cassandra. Cassandra is a example of a columnar database. It's the benefits specifically of Cassandra are its scalability. So it has the ability to scale linearly as you add more nodes to the cluster. Cluster is used to describe the collection of machines that are used to run Cassandra. And because of the number of nodes itself, you have distributed data across all those nodes. So it's an always-on architecture. You can implement replication across the nodes. You can implement replication across different clusters and geographic locations. Excuse me. So you can guarantee that you'll always be on and it will always be available. As I mentioned, it's also linear scaling. So if you're able to process X number of transactions a second with 2 nodes, you can double that by adding 4 nodes. It is pretty close to linear scalability, which offers an enormous amount of flexibility for organizations where demand is either growing or it's unknown and you need to react to it. So, for example, maybe during a high shopping period. Or if you're rolling out a new product, which is the case in this scenario where you have an initial install base, and that install base is going to grow over time. The other thing is that, in theory, these installations are using commodity hardware. It doesn't mean necessarily cheap, but it means hardware that's easy to get on the market. It's easy to operate and maintain because it's not proprietary. It's not custom. You can go buy these machines from your typical hardware vendors, and they will meet your needs. So the specific implementation of Cassandra that we're looking at is DataStax Enterprise edition. And basically, this is a version of Apache Cassandra, which is open source, that is provided and distributed by DataStax, the company. The advantage of using distribution from a company like DataStax is that you get a more mature and commercial-ready edition of the software. It's still the same code base, but they layer on services and they layer on utilities that really make this production hardened. So things like management services, having a management console, security, the ability to do search and analytics on the data where it sits. Also, they provide training and and services around getting the installation up and off the ground and dealing with bug reports and bug issues. So it's really important to make sure that you're going with software that is backed by somebody who will take responsibility for helping you with the issues. So now we'll move into a specific use case where Apache Cassandra was implemented in the organization and how we dealt with it. So in this scenario, we had a Fortune 50 telecommunications company was developing a new product. The product was basically their new DVR platform. There are millions of devices that are deployed out to customers, and those devices are going to communicate back to the data center. So if you can imagine what can be done on these devices, there's going to be a lot of transactions. So they had a need to deal with massive writes, so tens of billions of writes and transactions a day. The ability to access the data very quickly so that the devices that are communicating with the back-end system don't experience any latency or lag. They needed the ability to be able to change the schema quickly without impacting downstream services, but still being able to deliver new functions and features to the business without breaking what's currently deployed. They needed to make sure they did not have a single point of failure. They cannot allow the cluster to go down, because at that point, all the devices would no longer function, which would be a major impact to the customer base. Part of that is being able to distribute that load across multiple nodes to enable that linear scalability for the customer base, and also to allow for geographic distribution of the data so that it reduced latency based on your geographic location as a customer. So the way this played out was that the first iteration of this used traditional RDMS. And my experience was I was on the analytics team. I was actually a consumer of the data. We consumed the DVR data to provide insight into the business, and also the operations development teams to let them know how the product was running. So as I mentioned, the first iteration used Oracle, so we used traditional ETL tools to extract the data based on change date, load the data into our warehouse, and run business intelligence tools on top of it. Traditional type of ETL. This implementation did not meet the requirements that you saw on the previous slide. It was not performing at the level that they wanted. The number of transactions being processed per second was not fast enough. They had big concerns about the ability of the platform to scale, because the install base is expected to double over the next couple of months and keep doubling. And so there were some serious concerns. This is when they decided to go with a NoSQL platform. And what they did is they replaced Oracle with Cassandra. So Cassandra would give them the linear scalability and the ability to distribute load across numerous nodes and have extremely fast write access. The issue was that when this was put in place, it broke the existing ETL paradigm. We had to figure out a way to get the data out of Cassandra and into a platform that would support the analytics that they currently had. Excuse me. This sounds a lot easier than it really is. We had very specific constraints in the solution that we could develop. We had to make sure, one, that we didn't impact the development team. The development team was working on functionality, so we couldn't ask them to modify anything to support analytics. We also could not ask them to do things like create secondary indices, which I'll get into, or write the data in a different way. The specific problem was that the data was written at the device level, because the device is the item that communicates back with the application and ultimately Cassandra. The problem was we wanted to aggregate data across all devices, and we wanted to be able to extract data that changed. And we were not able to query that data without adversely impacting the production installation. And this is mainly because some decisions that were made early on about not running analytics on transactional platforms form, which is a pretty common practice. So why was this difficult to query data? On this slide, we'll discuss, why it was difficult for us to get the data out of Cassandra as it was implemented in the first run. Now, again, this is specific to the implementation that we dealt with. In a traditional RDBMS, we create tables and structures that support many different data access paths. By that, I mean, if we create a table, we can pretty much query by any column in that table. We have the ability to join that table to other tables, and we can improve performance doing things like creating views and creating indices. It's a fairly mature tool. What happens in the NoSQL world is it's a different paradigm. You are designing your data structures to support specific data access paths, and you're doing that for the blistering performance that you get. So fundamentally, what this means is that you need to duplicate data to support different ways of querying the data. And you'll see that specifically in the example on the next slides. So in a relational model, say we have a recording table where we have a device IP, and the device IP is part of the key, the set of columns that make this entity unique. We may have a program associated with that and a date. So a recording would be device A recorded Jersey Shore yesterday. And we may have some attributes about that they may be related to the program format, whether it's HD or SD, or the TV rating. But with this table, we can run any of these queries that you see here. We can query by the IP of the device. We can do aggregates and group bys on the program. We can do it by the recording date, and it's fairly straightforward. Now, this works at lower volumes of data, but when we started to get into almost trillions of rows, it became impractical for us to do this in a relational database with a table that is modeled similar to this. So in the NoSQL world, what you would do is create what's called a column family. So this is a specific example to both columnar databases and specifically Cassandra, where what you could do is create a column family with columns. What you see here is that each column family has rows with a row key and columns associated with that row key. Those columns are different than what you would traditionally think of in a relational world. The columns are tuples where each column basically has a name. So it could be format, the value could be SD, and then the timestamp that column was actually created. So all the data management basically happens at the column level. In this scenario, if our key is the same as it was before in a table where we have a device IP, a program, and a date, we're able to query by the device IP, but that's it. If you do any other type of query, it's either not going to be allowed or it could cause a full scan, which would be detrimental to the operational performance of the system. Now, why would you do something like that? Well, the reason is this is a sorted key where the device IP is the first value in that sorted key. So it would support extremely fast access for the devices, which is the number one point of the system. It's a transactional system. So we wanted to make sure that we provide very fast write access and read access at that level. Unfortunately, that means from an analytical standpoint, i.e. downstream stakeholders, as I mentioned earlier, it becomes very difficult to get the data that we need. We want to aggregate by things. We don't care about a specific device. We care about all the devices. And we also need to know when things have changed because we don't want to pull the whole thing down every time through our ETL process. So how do you get data out of a structure like this? Well, there's a number of different ways. One way is to use NoSQL in a traditional fashion and denormalize the data, and store it a second way. In other words, you're going to duplicate the data to support two access paths. And what does that mean? We could create another column family called recording by date. And in this case, what we'll do is we'll change the key order to start with date, and then this would allow us to do date-based querying. So that would allow us to do basically change data capture on the system. We would be able to query things that have changed since the last time we ran our ETL, and we could load the data into our analytics platform. The problem is that this would have required a change by the development team, and they would have had to basically modify the application to fork and write to two places at the same time. They would have had to write to the previous column family, which supports the APIs for the application and devices, and they would have to write to this structure here that you see on the screen to support the analytics. That was not a practical solution because, again, we did not want to impact the development team. We also didn't want to do analytical queries on the production nodes. There are ways to get around this without creating additional data structures. You could use things like the DataStax Enterprise analytics tools, things that come with Solar or Spark. You could create secondary indices. You can do custom solutions. In this specific use case, we went with the custom solution mainly because of the constraints that were put on us by the operational environment. It's not necessarily the only way to do things or the best way to do things, but it met the requirements of our situation. And so what we did was to build a custom process to get data out of Cassandra, process it in a Hadoop cluster, and load it into a warehouse. Now, all that work probably could have been eliminated if we had done a little more upfront work related to understanding the business requirements of downstream consumers and bringing in data architects and data modelers. In the end, after we were able to provide access to the data, we were able to allow for some pretty significant improvements to the system. When they went live, they were not able to query their own system. So the developers couldn't query their own data unless it was by the device ID. The business couldn't get insight into the data. Even the operations teams couldn't get metrics on some of the data they wanted. The reason being because it was difficult to query the data. We gave access to all that data, and we were able to improve the data quality, which allowed us to provide accurate account information to the customers and making sure that they got the experience that they were paying for. We also allowed the business to be able to do ad hoc based analysis of the data so they could understand how customers were using the data to improve the customer experience. They were also able to figure out ways to reduce the cost of the implementation based on customer behavior, things that were not possible without implementing some layer of analytics on top of the platform. Also supported linear scalability. So the Cassandra implementation itself will allow the customer base to grow, and the node can grow. The cluster can grow with it, supporting that customer base. There was no impact to the development team, which was a major component of this solution. We wanted to make sure that we did not slow down the development team, nor impose any constraints on the functionality for the benefit of analytics. And most importantly, we did not want to impact the operational performance of the transactional system. This is similar to what you would do in a traditional OLTP relational database implementation. You don't want to run your analytics on the transactional system if you don't have to, because then you don't commingle resource usages across multiple functions. So how do we see this all fitting together? We see that things like the NoSQL and the other big data tools as blending into the architecture to support a kind of layered approach to data management. I don't see big data tools coming in and replacing everything that's already there. That's going to be very intrusive, and it's also not going to be efficient, typically. So what we do is we see that some of the big data tools will be up front and they'll be responsible for managing and acquiring the extremely large sets of data, large volumes of data, the rapid flow of data, or the unstructured data, the stuff that's typically difficult to manage with an RDBMS. But ultimately, some of that data is going to make it down into an RDBMS through traditional processes. That will be data that's probably more on an aggregate level, or maybe it's less volume or it's more structured. And your typical data analyst will be able to access that data through SQL. Ultimately, that data will filter up into the web tier where we allow the business users to query the data through our traditional dashboards like Cognos or Business Objects. We support ad hoc queries. It's a secure interface where we're able to provide data based on the role of the user. The Hadoop world and the NoSQL world have a whole set of tools that are not typically SQL compliant, although they're starting to allow that feature. Typically, they're things like Hive, Pig, Splunk, MapReduce, or some of the specific NoSQL interfaces like command line interfaces. We see typically the data scientists operating at that level. Although it's possible that any of the people on the right could access data at any different level, we're just trying to illustrate that there's a level of aggregation and different roles of people that will access the data based on its life cycle as it filters down and aggregates up. So now I want to pass off to Ben and have him talk about our approach to a successful integration of big data and NoSQL in an enterprise. Take it, Ben.
Great, thanks, Todd. So how do we approach a big data implementation? The first thing that we always do when we're meeting with prospective clients is try to understand both some business and some technical questions. And getting to the bottom of what the right questions are to ask, I think, is critical. So, what is your corporate vision? Why do you think big data is important? Why do you think this is the route that you need to go? We need to ask that and have a discussion there. At big enterprise Fortune 500 companies, what we usually find or need to ask is, have you already started something? In many cases, we find that there are competing versions of a big data solution of a NoSQL or Hadoop installation that have already been started. And so understanding where those are in the organization and what they're being used for is very helpful. Data governance is another big area of interest from a big data perspective. If you don't have data governance implemented today, you're in a challenge spot as it is. Moving to a big data solution is going to exacerbate any data governance issues you have. So if we think about the amount of data now that we're going to be dealing with in a big data solution, and not being able to govern that, it can get out of control very, very quickly. So understanding where you're at on the data governance maturity curve is critical. And then is there a big data evangelist at your organization that is going to get behind the project, understands the value that we can get out of big data, and is going to be willing to change the organization to support a big data implementation? From a technical perspective, most of these tools are open source, and that raises a lot of questions with our clients on, do we understand what that means? There are risks with using open source software, and we need to understand what those are and make sure that we address them. What's your tolerance for downtime? Most of these tools are very scalable and able to run at an enterprise level, but we need to understand how downtime may impact your business, and that will allow us to architect things in such a way that we can keep machines up and running. Running of analytics on your hot data, are you going to be running real-time models as data is streaming in? That is a different architecture than if we're looking for a cold storage solution. How do we handle upgrades of all of these technologies? So if you've been following the news and big data, what you'll find is that things are moving very fast. There's a new technology stack almost daily, or at least upgrades to existing stacks. So how do we handle that? How do we keep you on the latest and greatest, but also have you at a place where you can be supported within your enterprise and feel comfortable? How much time are you spending on operations versus innovation? So I think Todd mentioned earlier that if you have a 100-node cluster, are you spending all of your time managing each one of those nodes, or are you spending your time working with the data on those nodes and trying to innovate? So that can be a decision point for going with just an open source solution or going with a distributed vendor such as DataStax. And then one of the things we also see is, are you prepared for experts leaving? People do leave. These are hot skills. And so making sure that you have a plan in place to train resources and make sure that you have retention plans available is really critical, especially in a hot field like big data. So our approach coming into our clients, key thing, understanding what the business objectives are. What are you trying to solve with your big data solution? I think Todd touched on it earlier. That is really, really important when we're talking about processing high volumes of data, that we understand how you want to consume that up front so that we can model and structure that data appropriately. Engagement of all stakeholders, making sure we know who in the organization is going to be working with, consuming the data that we're going to be landing into the big data environment. Understanding what tools you have in place today, and then understanding what tools you might want to use within the big data landscape, and doing a tool assessment and proof of concept around those to make sure that they're the right tool for you. I think one of the most important things is number 4, and that's using an agile methodology. The big data landscape is changing rapidly, and as we learn and adapt, we need to be able to have a framework that allows us to fail and try new things. And I think Agile is a great methodology for that and fits really well within the big data space because we know we can iterate and make sure that we get things right and be able to work with all the new tools as they evolve and mature. A hybrid architecture. So I think Todd touched on that a little bit. This is not or at least typically not a lift and shift of removing your current architecture and replacing it with big data. These tools are going to need to work within your enterprise. And so how do we create a hybrid architecture where all of these tools can work together and we can have NoSQL and Hadoop doing the things that they were meant to do and have the traditional tools that are already in your enterprise doing what they do best. And then finally, understanding the analytical requirements. So how are you going to get data out? How are you going to report? And where are you going to do that at? So those are the steps that we walk through with our clients when we approach a big data solution. And with that, I think we can open it up for Q&A. And I think we've got a couple of questions already. So I'll start with the question list, and then Todd, if you want to jump in and answer as needed, that would be great.
Sounds good.
All right, so the first question we've got is, how do you evaluate when your organization is ready to transition from a small data organization into integrating into a big data organization and using big data tools?
I typically see
Todd,
that. Oh, sorry, Ben.
Yeah, go ahead, Todd.
Yeah, I typically see that happening when the current tools start to break down. So the motivation often is that we're doing things right now with the traditional tools, and we just can't get the functionality out of them. And that could be because of the type of the data, the volume of the data. It could be for a number of reasons. But ultimately, this is probably the biggest motivator for people to move from small data to big data.
Great. So I got a couple more questions here. Just a reminder, if you do want to ask a question, you can use Twitter, hashtag CTWebinar, or hit us on the chat. So the next question here that we've got, we talked about NoSQL tools are intended for high volume data. How do you define high volume? I think that's a great question, and there's a lot of different answers. But Todd, do you want to talk about how you define high volume at your clients?
Yeah, the high volume is simply when we try and stick it into either Oracle, SQL Server, or any RGMS, and it just doesn't perform. It's a hard number to get your hands around because it depends on the type of data. and how frequently it comes in. But to give an example, we're looking at tens of billions of transactions a day. That equates to, in some channels, we have upwards of 7 to 10 terabytes of data a day coming in. But all that data is different. Some of it's wordy logs. Some of it may just be key value pairs. So it depends on the type of data. So there's no real exact number that once you hit it, you're big data. It's more of what I'm doing now can't support the data that I would like to get access to.
Great. All right. So our next question is around defining the differences between a table and a Cassandra column. So what would data look like in each? I think we had some diagrams on slide 24 and 25, Todd, where we were comparing and contrasting the difference between a relational table and a Cassandra column. Can you talk a little bit more about why a columnar data store is different from a relational database?
Sure. So in the relational database, we have a table structure where we typically have a primary key, which is illustrated in this example by the device IP, the program, and the date. And then we add columns to that table. And we can join this table with other tables. We can query by any number of columns. When we have more data, we create more tables or add columns. When we want to improve performance, we create indices. In the NoSQL world, specifically with columnar, we have something called a column. The column family is roughly equivalent to a table in the relational world, except that the column family contains a row key and a set of columns. And those columns are defined by a tuple, which is composed of the name of the column, the value, and a timestamp. So, for example, you could have here, the recording would be the column family. The key, so the actual data itself, would be a concatenation, literally a string concatenation or data type concatenation, the device IP, the program, and then the date. Any other data that we want to add, we can just add a column. There's no schema, there's no structure. Whatever the application writes in is acceptable. And so that means you have a variable schema if you don't have any data governance. So an example would be you could put in date, and you could actually call the column name could actually be the date value itself. So it could actually just be a timestamp. That's one way of doing it. You could actually put in a column name called date, put in the column value itself with the actual timestamp, and then have the third column, which is the column timestamp in the tuple, is put in by the client, and it dictates when that value is actually persisted. So you're actually persisting columns in a column family as opposed to persisting records in a table as you would in a relational world.
And I think the key point there is that making sure that we are modeling for the use is going to be critical to make sure we know how to get that data out easily.
That's correct.
Next question we've got is, what do you see in the marketplace for other NoSQL technologies, for example, Mongo or HBase? So I know, part of that depends on what problem are you trying to solve. I think the main competitor that I see in the marketplace to Cassandra is HBase, and I've seen both of them in a number of different organizations. I think it really, though, again, depends on what problem are you trying to solve. So, Todd, I don't know what you've seen out there in terms of other NoSQL technique or technologies.
Yeah, so the different NoSQL platforms are designed to support different needs. So things like, I mentioned the 4 types. You have the columnars, you have the key value. The key values are very typically lightweight, often used for simulating like a memory cache. That's how we're using it. We use it for very, very fast lookups, hundreds of thousands of rows a second. Things like CouchDB and MongoDB are document related, so it allows you to store JSON, XML, or actual documents and tag them and support very rapid lookup of that data. Things like Neo4j or your graph databases are really good for relationships where you have nodes. The nodes have attributes. The nodes have relationships with each other, and those relationships themselves have attributes. So that's good for data where there's lots of links and relationships between things.
Great. Thanks, Todd. So those are all the questions that we have today. If anyone wants to follow up or has additional questions, feel free to reach out to myself, Ben Harden, or Todd Homa, and I think our contact information is on the last slide. So if you want to move to the last slide, we can end there. Appreciate everyone's time, and thank you very much.
Thank you for your time.